All right, and welcome back. So today we are going to be talking about the third type of functions that we're going to be seeing this year. So far, we've learned about linear functions, and those are going to be a straight line. We learned about a quadratic function, which is a parabola, which has two curves to it. Today, we're going to be talking about what's called an exponential function. And this is going to be kind of, sort of, half of a parabola. Not really exactly. But to create some kind of connection, it's going to look as if it starts off linear and then boom, curves and goes straight up or straight down. These have a lot of real life applications to it, and hopefully we're going to be getting to a lot of them this year. So let's start out by first talking about the key concept of what an exponential function even looks like as an equation. So exponential functions are of the form y is equal to ab raised to the x power, where a is not equal to 0, b is not equal to 1, and b has to be greater than 0. So here's what we mean by that. The most important aspect of this, where students in the very beginning stages, they tend to forget, the exponent of x is only attached to b. We do not do a times b and then raise it to the xth power. It's b raised to the xth power, then multiplied by a. So this is how exponential functions look. Y is equal to ab raised to the x power, again, where a is not equal to 0, b is not equal to 1, and b is greater than 0. If you have not already done so, please jot that down, because I do not think your guided notes have this explicitly listed. So please make sure we copy everything we see in this screen down before you resume. These are what the graphs look like when it comes to exponential functions. These are the four types of visual graphs. And we're going to go more in depth with this, but I just want to show you how cool these look. They look as if on the left-hand side, when our b value is greater than 1, they start out really, really close to the x-axis. And then all of a sudden, they either shoot up or they shoot down. Vice versa, when our b value is smaller than 1, but still bigger than 0 on the right-hand side, it starts out very, very high and gets really close to the x-axis, or starts out very low and gets really close to the x-axis. So these are how exponential functions are going to look as we go about practicing and graphing these. So we're going to get more in depth with this, but just want to show you real quick the four types of graphs we're going to see. So an exponential function has the independent variable as the exponent, the x. Y equals 3x and y equals negative 2 times 0.5 raised to the x are exponential functions. A set of ordered pairs satisfies an exponential function if the y values are multiplied by a constant amount as the x values change by a constant amount. And that sounds very wordy and very tricky, but let's talk about how we're going to show that if a set of ordered pairs or even a table is going to be an exponential function. This is also on your guided notes, by the way. So we're going to tell whether the following ordered pairs satisfy an exponential function. So we have 3, 4, 5, 12, 7, 36, and 9, 108. What we want to think about, since we're talking exponential functions, we're going to be multiplying here. So we want to think 4 times what number gives us 12? 12 times what number gives us 36? 36 times what number gives us 108? Well, the x values increase by the constant amount of 2. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. And each y value is multiplied by the constant amount of 3. 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. Therefore, this is going to be an exponential function. Our x values increase by adding the same value. Our y values increase by multiplying the same value. And as you can tell, our numbers get drastically big as we continue this function. Let's do one more. Let's tell whether the following ordered pairs satisfy an exponential function. Well, we have the x values 1, 2, 3, 4, and the y value is 2, 4, 6, and 8. So we have to think about, hey, are our x values increasing by adding and y values increasing by multiplying? Well, the x values increase by the constant of 1. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4. But our y values are not constantly getting multiplied by the same number. 2 times 2 is 4, but 4 times 1.5 is 6, and 6 times 1 and a third is going to give us 8. So we don't have a constant ratio. So this would not classify as an exponential function because we are not multiplying by the same value of our y's. Here's a real life scenario. The population of a school can be decreased by the function f of x, or we see that as y, is equal to 1500 times 1.02 raised to the x power, where x represents the number of years since the school was built. What will be the population of the school in 12 years? So we have our given equation, we have our given function, 1500 times 1.02 raised to the x power. Well, x represents the number of years in the school was built, and we know we have 12 years. So we can substitute 12 for x. Again, this is written in function notation. We sometimes just see it as y is equal. Right now we have f of 12, yes, the function evaluated at 12. And we can plug it into our calculator, and we're going to round the number of people to the nearest whole number because we have to have whole people. And we get 1,902 students after 12 years. That should be a good prediction of how many students we should have. Awesome. With this, please work on problems 1 through 5 on the guided notes and resume when you're ready to move on. So again, let's go back to the graphs of these exponential functions. The graph of an exponential function is always a curve in only 2 quadrants. And again, our general formula is going to be, or equation I should say, is y equals ab raised to the x. So if your a value is greater than 0 and your b value is greater than 1, meaning that we're going to be getting bigger and bigger and bigger, your graph is going to be in quadrants 2 and quadrant 1. If our a value is negative, if it's less than 0, but our b value is still bigger than 1, meaning we're getting bigger and bigger and bigger, well, we're getting bigger and bigger and bigger towards the negative values. So we're going to be in quadrants 3 and 4. If our a value is bigger than 0 and our b value is smaller than 1, as we continually multiply, we're going to get smaller and smaller and smaller, but we're never going to cross over to the negatives because our a value is bigger than 0. It's a positive, so we're never going to go down into the negative aspects of it. We're going to start in quadrant 2, and we're going to go towards the x-axis in quadrant 1. And lastly, if our a value is negative, it's smaller than 0, and our b value is in between 0 and 1, meaning that it's not going to be getting bigger, we're going to be getting smaller. We're going to start in quadrant 3 and end up in quadrant 4, but again, we're going to be going towards the x-axis. And the more that we practice this, the more that we graph these, the easier it's going to be able to understand and apply these ideas. So let's graph y is equal to -3 times 2 raised to the x power. We're going to create a table of ordered pairs, and then we're going to plot the points. Since a is less than 0, aka is a negative number, and b is bigger than 1, the graph should look similar to the second graph above. Let's go back and look at that second graph. Since a is less than 0 and b is bigger than 1, it should look like this graph right here. So let's create our points. We're going to choose the x value of -1, plug it in, we get -1.5. We have the x value of 0, we plug it in, we get -3. We have our x value of 1, we plug it in, we get -6. X value of 2, plug it in, we get -12. Notice that all these are changing by a factor of 2. Negative 1.5 times 2 is negative 3. Negative 3 times 2 is negative 6. Negative 6 times 2 gives us negative 12. So our y values are increasing by a factor of 2. And the reason is we have a 2 inside our parentheses. 2 is going to be our b value. And when we plot these points, we're going to see that this is going to be our graph. Awesome. With this in mind, please work on questions 6 through 8 on the guide and notes. Y'all are doing super duper well. Keep up the great work. This is a new topic, so if you have any questions, please do not hesitate to reach out. Let me know if you have any questions. I'll talk to you soon.